So yes, Krishna, first of all, introduce yourself before entering into the snap of RCC, as you have interview in HPCL on dated
13th June, sir.
13th January 2023, right?
Yes, sir.
Yes, so go ahead, Krishna.
Sir, I am Chaitanya. I have graduated from VNR Vignan Jyoti Institute of Technology and Sciences, which is in Hyderabad in the stream of civil engineering. And then I have done my B.Tech project on widening of embankment using reinforced earth material, reinforced retaining wall using a software called Plaxis.
Okay, so your complete name is Krishna Chaitanya, right?
Yes, sir.
Okay, fine. So when you graduate, Krishna?
Sir, 2021, sir.
2021. Okay, after that, what you did?
Sir, actually, I gave my GATE in 2021, but I could not perform well since it was a Corona year. I did not study, so I just qualified. I just got 40 marks. So I thought to give attempt one more time with my full preparation.
Okay.
So I was preparing for GATE, but meantime there was a notification, government notification of assistant engineer in Andhra Pradesh. So I completely dedicated myself to prepare that job.
Okay. What is your home state?
Sir, Andhra Pradesh, sir.
Andhra Pradesh.
Yes, sir.
Who's the CM of Andhra Pradesh?
Sir, currently Jagan Mohan Reddy.
Jagan Reddy. Okay, so I think there is a mall named as Lulu Mall in Hyderabad.
Sir, what is the name of the mall, sir?
Lulu Mall. Have you heard about that one?
No, sir.
Lulu Mall.
No.
Okay, so you just go with the RCC or you prepared the pre-test concrete also?
Sir, you can proceed both the subjects. So I'll come to know where I'm weak. So I'll try to improve, sir.
Okay. What is the difference between RCC and PSC?
Sir, in RCC, we just design the members to sustain the loads. But in PSC, pre-stress concrete, we use some pre-stress in it, either tension or compression, which we need, so that it will be a compensating to the load.
Krishna, you said in RCC you are designing member to bear the load, but in
Yes,
pre-stress concrete member you don't want your member should resist the load or bear the load. What do you think?
Yeah, it will bear the load, but we are inducing some pre-stress in it, so that it will be an added advantage to bear the load.
Okay. Can you tell me the behavior-wise? Behavior-wise, what is the difference between this RCC structure and the plain pre-stress concrete structures?
Sir, behavior in the sense, like suppose if you take the beam and if you given a load on it, so below the neutral axis there will be tension, and above the neutral axis there will be compression. So we know the concrete is good in compression but weak in tension. So we put reinforcement here in RCC structures. So there may occur some cases where the reinforcement we provide may not be sufficient to take care of the tension developed. So that's why we go for deep beams, which is not economical for small structures. Like the depth increases, sir. If the load is increasing, then we have to increase the depth and the reinforcement. So, but if we go with the pre-stressed concrete, we initially induce some compression in the member in the tension side below the neutral axis, so that the tension which is supposed to be developed will be compensated by the initial pre-stress, so that we can decrease the depth which will be economical.
Okay, but I think we can go with the DRB. No, we can go with the double reinforced beams or sections. If load is more, rather than we are increasing the depth of the section, just increase the area of the steel. If the higher moment is there, then requirement of steel will also be higher, isn't it?
Yes, sir.
Then why you just want to go with the DB?
Like we prefer PSC in mega structures, like in metro, where the load will be in some thousands of tons.
Krishna, you are not understanding the question. My question was simple on the basis of the behavior. How you will differentiate between the reinforced cement concrete structure and pre-stress concrete structure? Okay, how you come to know what is the basic assumption in the RCC? That is your, you have the LSM, the live state method. What is the basic assumption? Okay,
Like
what you are taking, Krishna? In
sir,
the LSM, you in whole RCC, you are taking the concrete takes only compression and tension is being taken care by the steel, isn't it?
yes, sir.
Concrete is not going to take any kind of the tension. It is taken by care by the steel, and steel is not going to take any kind of the compression. It is taken care by the concrete, isn't it?
Yes, sir.
So how you ensure the concrete is not taking any kind of the tension? Or how you ensure the tension is developed in the section? How you come to know there is a tension in the section? How you come to know?
Sir, it's a like by bending behavior of the beam, sir.
See, this is a beam.
Yes, sir.
I'm just drawing. I think this is visible to you, Krishna.
Yes, sir.
Now this is made of, let be M25 grade concrete, RC
Yes,
beam. Now my question is that how you come to know there's a tension in the section? The tension has been developed. How you come to know?
sir, there will be some tension cracks in it, sir.
Yes, there are the cracks in it. Whenever cracks are there in the section, it means concrete is very poor in taking tension.
Yes, sir.
But in pre-stressed concrete, we don't have such phenomenon. In RCC, what we are taking, whenever there are the hairline cracks, it means the tension is being developed, and that tension is taken care by the what? Steel. Suppose if tension is there and there is no cracks, what it means? Concrete is taking tension. So we are not taking it in design. Na?
Yes, sir.
So this is the behavior was the difference. What I was asking Krishna, behavior wise क्या difference है RCC और प्री स्ट्रेस कंक्रीट स्ट्रक्चर के अंदर? तो प्री स्ट्रेस कंक्रीट स्ट्रक्चर में हमारा क्या होता है, ओवरऑल जो पूरा का पूरा सेक्शन होगा किस में जाएगा, कंप्रेशन में जाता है.
Yes, sir.
Isn't it? जबकि हमारा जो RCC होगा, what you said earlier, neutral axis, below neutral axis what we have in general? Tension. And above neutral axis
we have
compression. Neutral axis, tension, compression. But in pre-stress concrete section, overall, all your cross section will be under what?
In compression.
Compression. See. Okay.
Yes.
One thing that you told, the D beam. So can you tell me how you come to know the beam is D beam?
Sir, if the depth of the beam is more than 750 mm, then we call it as D beam. 750
mm, then it is D beam. And how we will take care of this depth when it is exceeding the 750 mm? What extra protective measure you will go with this D beam?
Sir, besides providing the normal reinforcement, we have to provide some additional torsional reinforcement, side face reinforcement, which is of 0.1% of total reinforcement. 0.1%, which is divided into two halves, like we provide it on both the sides.
0.1% of what?
The total steel reinforcement.
The total steel reinforcement that has been earlier provided in the section, right?
Yes, sir.
Is it okay? The steel already provided, you are just considering 0.1% of that one. On the basis of what you decided the beam is D beam. I think this is a cross-sectional dimension.
Yes, sir.
So here we have what? This is the kind of the area, gross area. This is in IS 456, you will find here the web area.
Yeah, very.
Isn't it?
Yes, sir.
My last question to you, Krishna. In slab, suppose we are using mild steel, or suppose we are using Fe415, that is kind of deformed bar.
Yes.
Same grade of steel, same grade of concrete in both the slab. One slab having mild steel, and the slab having this deformed bar. Which one having more deflection and why? Subjected to same loading, same support condition we have.
I think it's deflection.
Okay, so Krishna, I think right now I can give feedback to you. So what I ask you, although I just want to go with your this B.Tech project, but time was less, and we have Abhishek is waiting in the waiting room. So see, so what I ask you, what is the difference between the RCC and the pre-stressed concrete structure? So on the basis of the behavior, earlier you said that was fine. On the basis of behavior, I think I explain you कि आरसीसी के अंदर जो हमारा एजम्पशंस होता है हम ये लेके चलते हैं कि जितना भी अमाउंट ऑफ टेंसाइल स्ट्रेस होगा वो स्टील बियर करेगा और जितना भी कंप्रेशन होगा वो कंक्रीट बियर करेगा और ये इंश्योर करने के लिए कि कंक्रीट किसी भी तरह की टेंशन को बियर नहीं कर रहा है तो उसके सरफेस के ऊपर हेयर लाइन क्रैक्स आने यहाँ पे जरूरी है whenever there is a presence of cracks in the section what it means the tension has been developed but that thing is not true for this pre-stress concrete section because this whole section is being compressed by the steel. Earlier we are stretching it. When we snap the bar, what is happening? The steel will try to regain its original configuration. So definitely the resultant compressive force is acting on the section.
Yes.
Okay. And what I ask you here, you already told to me this when the beam is going to be deep beam. So what we are just increasing the depth of the beam. But see, deep beam is there, that is fine. Depth criteria is also fine. Additional steel that you said that is also fine. That is a side face reinforcement or skin reinforcement. What is the area of that? Answer is the 0.1% of the web area, and this is equally distributed in the both sides.
Yes, sir.
What is the maximum spacing of the steel? Side face reinforcement or skin reinforcement?
For side face, I don't know, sir. Normally we keep 300 mm.
Yes, that is the maximum.
Yes.
You will never exceed spacing 300 mm. So slab, if we have Fe250, Fe415 grade, just see the IS456. Whenever we are providing this deformed bar in slab, what is happening? The depth requirement, Krishna, the depth requirement to control the deflection is more. It means अगर हम slab में deformed bar दिए हैं, Fe415 दिए हैं और हम चाहते हैं हमारा जो slab है वो परमिसिबल लिमिट के अंदर ही हो उसका डिफ्लेक्शन, तो ये जो आपको डेप्थ प्रोवाइड करना होगा स्लैब के अंदर ये ज्यादा होगा, स्लैब की डेप्थ ज्यादा होगी. But in case of Fe250, this depth requirement is less. Now see, you must go through these clauses. This effective span to overall depth ratio, this should be less than what? This is 40. When we are using this Fe250 grade steel, simply supported. I think this is simply supported. Simply supported beam or slab. If you are using this Fe415 grade, then this is kind of 0.8 times of this one. The value will change, na? I think here's a 35, I think so. Simply supported here, we have 35. So what is the value of 35? 0.8 of 35. 28?
Yes, sir.
28? 28?
Yes, sir.
Now you can see कि simply supported slab, effective span, ये डिफ्लेक्शन को कंट्रोल करने के लिए क्लॉज है IS 456 के अंदर. इफेक्टिव स्पैन और ओवरऑल डेप्थ का रेशियो 35 से कम होना चाहिए जब हम माइल्ड स्टील दे रहे हैं स्लैब के अंदर. अगर हम मान लो डिफॉर्म बार दे रहे हैं तो ये रेशियो मेरा 28 से कम होना चाहिए. नाउ सी, अगर मैं यहाँ से ओवरऑल डेप्थ निकालता हूँ देन इफेक्टिव स्पैन डिवाइडेड बाय 35, डेप्थ शुड बी ग्रेटर देन दैट वन, और हियर इफेक्टिव स्पैन डिवाइडेड बाय 28, डेप्थ शुड बी ग्रेटर देन दिस वन. Here the value will be less because denominator is large. Here value will be more because denominator is less. Suppose having the same span what we have when we are going with the mild steel, same span what we have when we are going with the deformed steel. Are you getting what I'm trying to say here?
Yes, sir. Yes, sir.
Just go with the clauses what IS code is saying.